棒のトマト、棒のトマト、棒のトマト、赤上げて緑下げてトマトマトマト。
What is gravity?
I have no idea. Okay, next question.
Wow.
No, here's the difference. We can describe gravity. We can
Okay.
say what it does to other things. We can measure it, predict with it. But when you start asking like what it is, I don't know. So to say what is it? I think Einstein, in an Einsteinian answer, we would say gravity is the curvature of space and time. And objects will follow the curvature of space-time, and we interpret that as a force of gravity.
In 50 years, we treated gravity as if it was a force like any other. That model explained both falling on Earth and orbits in space. It seemed universal. But about a century ago, we learned that model is wrong. Gravity is actually curvature of space-time.
Newton and his contemporaries had a real problem with that law, namely that it didn't seem to, it described gravity's effects, but it really described how gravity works. And Newton actually in his own life tried to develop, unsuccessfully as it turns out, an understanding of how gravity works. What is actually communicating the influence, for instance, between the Earth and the Moon or between the Sun and Mars, etc. And he really fell to Einstein. Einstein's role here was to really fill in that mechanism. He explained how is it that objects, massive objects, exert what seems to be a force on one another. Now, literally, it's not a force. So the thing about Newton's laws, you can't take it literally, but Newton himself didn't. Newton had various ideas on this, but generally it's thought that Newton did not take his own law that literally, that there is a force reaching from one object out to another. Specific idea that the force is non-local. In other words, that Earth reaches out as though by magic to hold on to the moon and grip it.
So obviously Newton thought that gravity acted instantaneously.
Instantaneously, but even more than instantaneously, is that it didn't propagate through the intervening distance between the objects. So there was really no way that the force got from one place to the other.
Wait, didn't Einstein say that gravity is not a force to begin with? Ah yeah, there's that. Einstein's theory of general relativity tells us that the effect we call gravity is different from normal forces.
For centuries, gravity was described as a kind of attraction between objects. Then Albert Einstein discovered that gravity is actually a warping of space and time.
So gravity must be a force, right? It's not. Isaac Newton described it as a force, but today we say that when something falls and accelerates, no force is making it do that. I loaded my phone with an accelerometer app and attached it to a camera. Here are the axes of this setup, X, Y, and Z. When I accelerate the system in the positive direction along an axis, I get a positive acceleration reading in that direction. Sitting on a surface, it says that it's accelerating at 1 g, 9.8 meters per second squared. Yet, unlike a car speeding up, it isn't going anywhere. Now let's see what happens when I drop it. It registers 0 acceleration as it's falling. Newton's second law of motion says that force equals mass times acceleration. So, if the acceleration measurement is 0, then any measurable forces acting on the phone must also be 0. Gravity must not be a force that causes the phone to fall to the floor.
Hé, Canadé, c'est la tomate!